Welcome back to Engineered Coffee. This is episode 21 already. This is about pressure, flow, and extraction. What really happens in those 25 seconds? Capsule machine has one button. You press it, and about 25 seconds later, your coffee's ready. It feels simple, but inside that capsule, in those 25 seconds, pressure builds up, materials flex, water accelerates, gases expand, oils emulsify, and flow paths continuously change. What you're drinking isn't luck, it's controlled physics. Today, we're going to talk to you about what really happens after you press the button. But before we do, please like and subscribe and share as usual. Thanks in advance. So let's get this straight. Pressure is not extraction. Let's start by killing the biggest myth in coffee. Pressure does not extract the coffee. Flow extracts the coffee. Pressure is simply what happens when water is trying to flow and something resists it. The pump pushes water forward. The coffee bed resists. Pressure builds until the resistance is overcome. And then, only then, does flow begin. And only during flow does extraction happen. If pressure alone made coffee taste good, we'd all be drinking hydraulic oil. So from this point on, remember this. Pressure is the consequence. Flow is the process. Extraction lives in flow. The moment you press the button, several things happen almost instantly. The pump starts, water heats rapidly, the hot water hits the capsule. But here's the key detail. The coffee is still dry. Dry compacted coffee is incredibly resistant to flow. So in those first few seconds, water doesn't move forward. It stacks up. The pressure rises quickly, and this is why capsule machines don't jump instantly to full pressure. They ramp up. The system is waiting for the coffee to hydrate, swell, and open up microscopic paths. Until that happens, the pressure climbs, but nothing is extracting yet. At this point, the capsule is essentially a sealed pressure vessel. Now here's something almost nobody talks about. The capsule itself is not rigid. Under pressure, aluminium capsules flex, fiber capsules swell, plastic capsules creep. This means that the internal volume of the capsule changes during extraction. The coffee bed shifts, contact points move, flow paths evolve. You are not brewing coffee inside a fixed container. You're brewing inside a container that is changing shape while you brew. This is one of the hardest things to engineer around because it's dynamic, not static. Eventually, the water wins. The coffee hydrates, CO2 begins to release, microscopic channels form, and the pressure increases to the point that the front foil ruptures and then flow starts. If you listen carefully, that's when you hear a small pop sound. This is the moment extraction actually begins. Now, people love to talk about channeling like it's always bad. In capsule systems, that's not true. Controlled channeling is necessary. Micro channels form. Without it, flow would never stabilize. The goal isn't zero channels. The goal is predictable channels. This is where everything you've heard in earlier episodes comes together. The grind distribution, the densification, the tamping, the capsule geometry, all of this exists to guide flow, not to stop it. So now we hit the balancing act. If flow is too slow, extraction runs too long. Bitterness dominates, body collapses, pressure spikes, and the capsule stress increases. If flow is too fast, you get under extraction, sourness, thin mouthfeel, and weak crema. Capsules don't have a barista adjusting grind on the fly. They don't get a second chance. Flow rate is the recipe. Typical numbers look like this. Espresso capsules, roughly 14 to 18 seconds, and Lungo capsules, roughly 25 to 45 seconds. Pressure limits generally between 15 and 19 bar, depending on the system. Miss those targets, and the cup falls apart. Flow inside a capsule is controlled at 3 points. First, the water entry. Needles or piercers decide where the water enters and how evenly it spreads. Second, internal resistance. The coffee bed and capsule shape determine the flow path. Third is the exit restriction. The lid perforation and outlet filter defines how pressure releases. In the case of an espresso capsule, what is called a pyramid plate breaks open the top lid and has very small holes that are essentially the filter mechanism. Put together, the capsule becomes a disposable hydraulic circuit. Hole size matters, number of holes matter, lid embossing matters, needle sharpness matters. Change any one of these, and the entire pressure flow relationship shifts. Let's briefly talk about the crema, without going into too deep yet. Inside the capsule, CO2 is trapped under pressure. As the coffee exits, pressure drops suddenly. The gas expands, oils emulsify, and the foam forms. Crema is not an indicator of strength. It's an indicator of gas management. We'll go much deeper into this in the next episode. When you design a capsule, you're designing for chaos. Unknown water quality, unknown machine age, unknown usage patterns, unknown storage conditions. Yet you must deliver stable pressure, controlled flow, predictable extraction every single time. Capsule coffee isn't simplified espresso. It's espresso engineering on hard mode. So the next time you press that button and coffee appears in 25 seconds, remember what just happened. Pressure is built, materials flex, water accelerated, gases expand, flow was controlled, and all inside something a little bit bigger than your thumb. That's not convenience, that's engineering. This has been Engineering Coffee again. See you in the next episode. And please remember to like, subscribe, and share. See you next week.